Great. So I want to start. We were in the Kiwi office, which is motion central, right, in the IoT world. And I want to first, if you guys could introduce yourselves, and then tell me a little bit about what you're up to in the space.
Sure. So I'm John. I'm leading the technology development at Kiwi. My background is in a variety of large-scale industrial applications of sensors, and that's a lot of the pretense of how the different methods that were put in place for Kiwi were formed, was the understanding of large infrastructure systems and how to take a multitude of thousands or tens of thousands or millions of sensors, combine them all into one and get a singular output or a singular kind of data point that can be actually utilized by an
So, I mean, you guys are in the business of understanding movement and
Yes.
understanding the subtleties and then the data behind that movement.
100%. Yeah, and motion's just one portion of that. And the signals and sensors are all very similar in nature. But the easiest for people to understand in the current marketplace of where IoT is today, motion is sort of the starting point for that sort of sensor translation.
So give me a sense, somebody comes into the office,
Yep.
what do they want to usually do? They say, hey, can you make my, can you make this particular object, tell me a little bit about how it moves, and then I need to analyze that data and make it into a smart object. Is that so? Give me an example of what.
Yeah, for sure. So let's take hockey as an example. I want to be able to differentiate and capture the passes, the shots, the different types of shots, and the different types of passes when I play in a game. Can you tell me about those things or detect those things with a sensor on a hockey stick or make a hockey stick smart?
Mm-hmm.
And we'd be like, yes, of course. And then go start into the technology of how we'd go about implementing it.
But is that sort of like putting what people are used to in a smartphone, the gyroscopes and the other sort of sensors that are onboarded onto a smartphone and basically embedding them form factor wise into a hockey stick? Or is there more to it?
That's the first step, right? So when you want to make something smart, it has to have certain qualities about it. The first one is that the smartened object, has to transmit data, right? So you've got to build that capability into it. So what you said about building accelerometers and gyroscopes into the form factor gets us that far where now it can speak and say, this is the data that's coming off of me. The next step is to take that data and then understand that language, right? So basically, the way you think about it is that the hardware and the little end cap that would go onto a hockey stick is just giving it the ability to communicate. The next step is to really understand what that language is and what that hockey stick is trying to tell you in various situations. And that is the core of what we enable our clients to do.
So data analysis, the ability to take that,
learn,
right,
based on an incoming data stream, what it contains,
right,
and repeatedly identify commonly occurring activities or commonly occurring words in that language,
right,
and say, this is what's happening right now, this is what and then build that with additional intelligence around, if I say this and I'm in this location, or if I'm in this state, this is what it means.
Got it,
Right?
got it. So it's not just the fact that you have now a new language, which is the language of motion. It's the ability to interpret that and create some sort of analysis on that to basically to create a narrative so that you can understand the context of that.
It is exactly just that, right? We're enabling something to speak, then we're processing a few words, then we're processing kind of all the words, and now we're saying, well, when you're in this environment and you say this, and this is what it means.
Right, right.
If you if I want to put a very rough understanding of it, it'd be like a search engine for real life. So how do you understand your movements or your things that you do in your day,
right,
in a real life context, and bring that to empower an individual. So
give me an example of a search engine for real life. Have you got anything here that you're working on or illustrative of that point?
Sure. So let's say it's like a smart bike helmet.
Right.
So there's a motion sensor and perhaps a brain sensor embedded into the helmet. There's two things that could be detected with those. You could use it as a method to interact or perform better, I guess, detection or If you were to fall off your bicycle, you'd be able to use that as a register event and tell someone.
What's a brain detector? Sorry.
Yeah, so a brain detector would be like.
He's like, are you
so
alive?
You're reading your
EKG?
No.
EEG. EEG. Sorry.
Yeah.
Yeah.
You read 3 brain waves from your brain, and
Right.
there's certain patterns that exist there that are
Got it.
indicative of, let's say, a concussion or
Got it.
things like that, or if you're falling asleep or things like that. So
Yeah, which isn't great in a bike.
no, isn't
No.
great.
Or if you're trying to do turn signals, right?
Yes.
So if you kind of go like this,
Right.
and it turns the signal on to go to the right, and go like that. and
Got
the
it.
left
Got it.
signal
Got
on.
it.
Right. And what I meant by search engine is there's all this data coming from sensors, right?
Right.
But that's usually meaningless to someone. You have to be able to search through that data and provide valuable outputs for it.
Kind of like how voice recognition works, right?
Exactly.
Like you send it, you talk into it, and then over time it is supposed to be able to say this is what you mean and this is what you're trying to say.
Yep.
In an Internet of Things space,
Yep.
it's not just humans that are communicating; it's machines.
Yes.
So what we've already built is an engine that is similar to how voice recognition is, but it talks to every sensor.
Got it. Got it. So you got bike helmets.
We've
You've
got bike
got
helmet, we've got
you've-
drones.
yeah. You got these little drones here
moving
that
your hand.
whoopsie, broken drone.
I think that
Yeah, yeah.
talking
These
about
guys.
the drone brings about a very interesting angle.
Right.
Motion is also a very important source of interaction,
Yes.
right? So
Right.
if you look at it like for a long time ago, we used to interact with technology by way of keyboards.
Right.
And then smartphones came out and we still interacted with technology by way of smaller keyboards.
Right. Right.
And then out came screens and we started to interact with technology by touch screens,
Got it.
right?
So like a surrogate, so it's like
The
an
next
intermediary.
step-
Yeah.
So if you look at it,
Yeah.
the market expected voice to do the exact same thing. Voice is a source of interaction. So if you think about it, when Siri came out, it broke all records for iPhone sales.
Right.
Because you were like, oh wow, I don't need to touch my phone anymore. So if you kind of keep that train of thought going, there's an inherent demand, and we see it all the time with kind of products that we put out there, for people wanting to do kind of what they see in the sci-fi movies like Iron Man and Minority Report,
Right.
where you go like this and it does something, and you go
Right.
like this and something zooms. All of that is
That
becoming
magic,
possible.
that magic wand. Well, we were talking about this the other day. You know, the M to M, which is somewhat what you guys are in the business of, is now M with this huge human in the middle,
Yes.
and humanizing all the telemetrics and that
Absolutely.
information.
Absolutely. So, I mean, the applications for this kind of technology are so broad that, you know, one of our big challenges is just staying focused, right? Think about any sport. Like, think about like cricket, right? Like, you've got a cricket bat, any stick sport, baseball bat. If you have a sensor here, it starts to say so many things about bat speed, angle, reaction time,
Right.
which is all amazing information that if I had available when I was a child, practicing every day in my backyard, would be so much more fun, right?
Yeah.
So, any stick sport, definitely there's a lot of like if you look at it with a different angle, where you look at different segments of the population,
Right.
we want to track kind of how healthy and active seniors are. If they take a spill, if they fall, you know, where do we need to go to help them? If they fell in one room or the other, how active they are is directly
But I think the big thing here is that motion. We've been spoiled. That's been on phones for a while. But what you're saying is, look, that's great. However, we need to embed that into
all
the objects that we're around, because ultimately we don't want the keyboard interface. We don't want to have
We don't
these.
need it.
We don't want an intermediary.
Yeah.
We want somebody to record the way we are, just as we record what you're doing right now, because we understand what you're saying. We have a human
Exactly.
interface.
with the least amount of
But that's not necessarily true, because humans are like silent by nature, so we spend most of our time in our brains.
Right.
We need a method to interact without feeling uncomfortable, and that's the purpose of the keyboard and the mouse. Is that provides
Got
that
it.
uncomfortable kind of
A channel.
It's a
Yeah.
comfortable
Yeah,
channel
yeah.
that people can interact with the machine.
Right.
People like waving their arms around and kind of dancing to interact with their computers. It's something that, you know, most people would be comfortable with. You have to be quite extroverted to
Right.
to do that.
Yeah.
So it's just kind of like a bridge or.
But it doesn't have to be. I mean,
No,
well, from what I understand from what we discussed here,
Yeah.
it's not about using my hand to gesture and control things
Yeah.
as much as I am controlling
Yes.
my world.
Yes.
I'm holding this camera
Yep.
as stably as I can. I held and dropped the drone. The bottom line is what you're talking about is how then can we take those motions and
Yes.
create some business logic that may be relationship it may correlate back to me, but also can be aggregated, right?
Yes.
Absolutely,
Yeah,
and I mean, there's so many use cases, right? Like,
Yep.
for example, when you're gonna leave this meeting, you're gonna put on your jacket. It should send a notification to your next meeting to say you're on your way now,
Right.
right? Like lots and lots of those things.
Yeah.
I think there's two things. One, the way we've set up our tech, it works in the aggregate, so it works across the vertical of people that are going to put on their jacket and it's going to do something for
Right.
them. At the same time, it's very personal, right?
Right.
So it has to work for you
Yes.
before it's useful to anybody else.
Yes.
Right.
And that's kind of our focus, right? So we
Got
want to
it.
make sure that an individual who's using our tech for the first time has such a pleasant experience with it that they're like, okay, this is awesome, and I want to use it for other things.
Got it.
And I think that multiplier effect will come as more and more things get connected to the internet.
Right.
Then you'll want to talk to your coffee machine, and
Right.
you'll want to talk to your fridge.
Which is really that Steve Jobs phenomena in 2007 when he did something,
Yeah.
we adopted it, we loved it,
Yes.
and we said we can use this for a whole pile of things, and then the app world exploded.
Exactly.
So cool. Well, listen, it's great chatting with you guys. Thanks so much for sharing with those insights with me, and I look forward to speaking again soon.
Awesome.
Thanks
you so
a lot.
much.